Howdy. Good. I got a response on the first time. That's awesome. That gives me very good hope for this presentation. Can everybody hear okay? I'm not sure if I got the mic in a good spot. Everybody's good? All right. So how's RVAsec going for you guys? Good? I'm just filling time because I have nothing to talk about today. So I'm kidding. So welcome to DevOpSec, killing the bugs. Bugs, both, I guess. I just kind of want to start off a little bit and kind of gauge where people are on this. So what were you expecting from this talk? When you saw this title, were you thinking technical? I'm going to show you how to break DevOps tools. Were you? No? Yes? I'm sorry to disappoint you because that is totally not what I'm talking about. Figured I'd get that out of the way first. Everybody that's expecting that it's not going to happen. Consistent proof that DevOps tools work? Any existing proof? I might have some of that. We'll see how that goes for you. Okay, so I guess just to set that expectation now, this is not a how to break DevOps tools. This is not a technical talk. This is more of kind of a how the heck do I get my DevOps teams and my security programs working together and interoperating? What tools are available to me to do that? Why should I do that? Is it even possible? And so that's kind of the ground level that I'm going to be at for this. So hopefully that's what you're looking for out of this, because that's what you're going to get. So helps if I plug in the USB dongle in order for the thingy to work. So first off, who am I? Hi, my name is Jason. I'm a security consultant with the NCC Group. We're a very large pen testing firm. You can find me online at Twitter as RVAsec. You can find me pretty much every place else as Algorithm. So if you look for me, you can find me. It's pretty easy to do. Special note about this presentation, just so you're aware. Obviously, this is DevOps, so there are super many buzzwords. So anytime I include a buzzword in a slide, I will also include this. So you'll know that there's buzzwords. So we'll have fun with that. So what's the agenda? So we're going to set the stage a little bit. We're going to talk about blue teams. We're going to talk about red teams. We're going to talk about how they fight. We're going to talk about tricks. Tricks are for script kiddies. We usually use script kiddie in a negative connotation. In DevOps worlds, scripts are good, right? So tricks are for script kiddies. We'll talk a little bit about techniques and tools that are available for that. And then we'll wrap up. So that's kind of where we're at with it. So first up, blue team. Who knows what the blue team is? Anybody? Shout it out. Defenders. Defenders, right? So this is your DevOps teams, defenders and security, but it's also your DevOps teams. This is your operational staff, your system admins, this is your developers. Sometimes they're the same people. Oftentimes they're the same people and you don't know it. So this is who this team is, right? So what do? They do that, and I'm not even going to try to read that slide because it's just super crappy. But basically, the main goal of DevOps is to break down barriers between organizations, right? So businesses have these silos. You've got your system admins, you've got your developers, you've got your QA, you've got all these different silos. And DevOps is saying, you know what? This is getting in the way. We can't get stuff shipped fast enough. We need to get this crap out of here. Let's break down those barriers, get our teams all talking together. The problem is those silos are there for very good reasons, right? Like they came out of ITIL. There was a whole lot of research and study done on this. And the outcome of that was, we need to reduce fraud in the business world, and we're going to do that by siloing everything off. So now we're saying, screw that, we're going to smash that, and that's not necessarily good. That does not expose us to fraud again. So there's some challenges to overcome with that. So what are the goals of DevOps? Rapid development, right? We want to get things out fast, now, internet speed, right? Continuous deployment. We want everything to be going all the time, just constantly pushing to production. We want to scale quickly, and we want to be able to roll back instantly. Those aren't necessarily bad things, but they're definitely different than where our traditional business models are. And if you've gone through IT for any number of years, it's definitely a change from where we're currently at. So how do they do these things? How do they achieve these goals, right? They do continuous delivery, deployment, integration, measurement, whatever you want to call it. It's continuous something, right? So they use cutting-edge next-gen techniques to get things done. They use a lot of virtualization, and I use that term loosely here because arguably things like Docker aren't necessarily virtualization as it's traditionally called. So I get some grief sometimes for calling Docker and things like that virtualization, whatever. Most people know what that is. So revision control, lots of revision control is in use here. So for the continuous stuff, how are we doing that? We're orchestrating, we're automating, we're using Docker, we're using different tools, we're using Jenkins, we're using Chef, Puppet, Ansible. Like, I'm just throwing out names, right? Like, we've heard these names all the time now. For orchestration, we're using things like Kubernetes, Swarm, things like that. Virtualization, it's cloud and containers, right? Revision control, Git, basically. I don't know if anybody's using anything else, but Git's kind of the ubiquitous tool for that. So basically, all these tools that we have are to set us free, right? DevOps wants to be our hero. They want to set us free and give us all the freedom that we need, and they want to be able to make our lives better. In the meantime, we've got the red team. So who's the red team? Attackers or security, right? Doesn't necessarily have to be attackers. In the context of this, it's just the security team, whether that's offensive security or defensive security. So what does security do? What's our goal? I assume most of us are in security, so let me just back up a second. Is that true? Most of us here are security? I assume since it's a security conference, that's true. Okay, cool. So security is CIA triad, right? We want to keep things secure. That's our goal. We want to serve and protect. We're like the police. We're friendly. We want to protect your hosts and data. We want to protect the business, and we want to protect end users. Depending on what type of application you have, the end users could be your customers. It could be internal end users, whatever. So how do we do that? 3 ways, right? We've got policies, we've got audits, and we've got simulation. So policies, we create them, we enforce them. Audits, we do compliance testing, we do log management and review. Incident response could potentially be considered an audit task. Simulation, that's where pen tests, phishing, social engineering, stuff like that comes from, right? So all these things together in the DevOps world, right, it's got to start with continuous. So we have continuous annoyment. That's what security is for DevOps. Basically, security wants to bust kneecaps, right? We want to slow the business down. That's the context of a DevOps environment. Because in a world where everything needs to ship now, everything needs to be continuously spun up in production, security coming in and saying, well, you can't do that. We want to bust your kneecaps. We want to hobble you. And as business, we don't want you to go this fast. That's why we get things like this. And it wouldn't be a DevOps talk and a security talk without this slide. So that's why we get this, though, right? There's this conception that the DevOps team is just pooping all over our product and our business. Security's there to shovel it up and try to fix it and patch it up and make it compliant again. So how do we meld those two worlds together? Those are like superopposed things. Can we even meld them together? Okay, so at this point, basically from here on, the buzzwords are just ridiculous. So I'm killing Samuel L. Jackson at this point, just for that. So there's common conflicts, right? So we've got 3 specific areas. First one is access control. So what's the DevOps method of access control? Does anybody know? Everyone can access everything to get things done. So my developers are getting into production because that's where they need to be able to go to fix problems immediately. If a user has a problem, they need to be able to respond like that. And the only way they can do that is if they have access to production to fix the code there, right? What's InfoSec's world of that? Hell no, right? You don't get access to production. We've got to have least privilege. We've got to have separation of duties, right? We've got to have the DBAs only can touch your databases. You can't go in and touch that. You're a developer, right? So we've got this, again, diametrically opposed thing. We've got process flow differences. So DevOps says everything's got to be rapid and constant updates. We have to update in production because that's how it works. If we're not updating in production, then we're not doing it right. InfoSec says, no, we've got to have strict reviews along the way. We've got to have these different check-in points, right? We've got to have isolated environments. Your dev box needs to be one environment. Your QA box needs to be another environment. User acceptance, testing, however many different environments you have, they need to be siloed and isolated. You have to have clear, defined check-in points between them, right? There is no, I'm just going to push it into production. And then finally, it's just a general culture and mindset difference. DevOps we need to be able to do whatever we want to do because we need to be able to play with ideas, right? So the DevOps world is, they've got this concept of, we want to try out a new feature. So how are we going to do that? We're going to split our user base up, and users over in this group are going to get this new user interface. still going to get the same old interface here, but we need to be able to do whatever we want to do because we need to be able to make these changes real-time automatic. InfoSec says, you can only do what we want you to do, right? You can only do what we let you do. That's the differences there. So how do we meld those two things together? Because the thing is, the DevOps world, that's a good thing for business. It allows it to be flexible. It allows it to react quickly to user needs. It allows you to react quickly to competitors, right? Because competitors are doing DevOps. So if they're doing X, Y, and Z thing, you need to be able to respond quickly and flexibly to be able to meet that same thing. Just to give you some context for like how many changes we're talking about here. In 2014, this is the best statistic I could find. It's a few years old. But in 2014, Amazon deployed 50 million changes that year. It's roughly an average of more than one change every second. Good luck auditing that. You just can't do it. You can't respond that quickly from a security point of view. So we have to figure out how to manage this giant fire hose of change that's blowing in our face. You're certainly not going to be able to go through a pen test for every one of those changes, right? So it's an interesting problem. And if you look at it from that context, we've ultimately got different goals, right? Dev wants to build cool things. Ops wants to run cool things. And security wants to break all the things. That's our goal, right? So we end up with this, basically. And I wish there was like a magic bullet solution that says we could get these two things to work together. But we really can't. This right here is the most key slide I have, because this is the only way you're going to be able to marry these two things together. You're each going to have to check your egos, right? Developers are going to have to check theirs. Security is going to have to check theirs. You're going to have to figure out how can we make these tools do what we need them to do to be able to move the business forward. Until that happens culturally, you're not going to be able to marry these two things together. And I think it's important, too, I guess I need to make this clarification. There's some environments where you can't marry these tools together, right? So if you think of like a traditional SAP environment, for example, there's no way you're going to be able to DevOps your SAP tools. You could do certain parts of it, right? So you're still spinning up databases, you're still spinning up hosts, so you can apply some of the techniques that we're going to talk about next to doing those types of things. But your GUI developers and things like that, they're not going to be using DevOps in SAP land. Mainframes, anybody that's still got those, you're probably not going to be using DevOps tools for a lot of that type of stuff either. So part of this is going to be like, where does it make sense to apply DevOps tools and where does it not? So we've got this, we need to check our egos, but at the same time, we've got every security pro ever saying this. I wish developers would get us involved sooner. Why is it always they get us involved at the last minute, and now I've got to come in and pen test this, and they're like, I need to go production today. Do your security test, right? And we're always asking, why can't we get involved sooner? In the meantime, every developer and sysadmin is saying, I wish security would stop getting in our way at the last minute. Well, guess what? Good news, everyone. DevOpSec is a thing. So another word for this, if you guys have ever heard of this, is rugged DevOps. This is actually the cover of the book, Rugged DevOps. Look how friendly it is. I hate this cover because it looks like we're going to just beat you up. Okay. So that's kind of setting the groundwork. Now I'm going to go into how does security integrate into the DevOps life cycles. Right, so the development cycle has kind of some generic phases, right? So we've got a design phase, development phase, a deployment phase, and a maintenance phase, right? Everybody agree? That's kind of where the development life cycle is at? All right. So security gets involved in every aspect of that. It doesn't get bolted on at the end in a DevOpSec life cycle. It gets involved right up front, even in the design phase. So how does that help security? We get continuous security delivery, right? We get continuous monitoring. We get an improvement of security awareness. This is key, I think. If you go back and you start this program where your security team is working with your developers, suddenly you've improved security awareness throughout your entire organization, right? Because your developers are now up front saying, we need to get engaged with security, we need to start thinking about security as we're coding. So that's critical. So what's continuous security delivery? It's using the pipeline to meet compliance and audit objectives. Continuous delivery lends itself to rapid patching, right? So this is kind of a neat thing. And I'm going to go through a little bit in a second and talk about each of these points a little bit more detailed. Monitoring, we can use feedback loops. The same feedback loops we're already getting to our developers to talk about these new features that they're spinning up. We can do something called attack-driven defense, right? So as we see attacks coming in real time, we can spin up changes. And we can say, instead of, hey, we want to try out this new color scheme on the UI and see how users like that, spin it out to this group. We can say, hey, we're seeing a whole lot of attacks of this particular type come in. Let's add a feature to prevent this attack and push that out, right? So you can get that out quickly. Security awareness, again, everyone's involved. So how do we do this? We inject code analysis into the development process, right? Right up front, we're doing code analysis. We can enforce fixes prior to the deployment. So your developers are already writing code, pushing it out. They've got automated processes in the pipeline that are doing things like compiling the code, doing lint, and running checks on it for some basic sanity, right? They're saying, are you doing whatever? Are you, did you forget a brace or a quote or whatever? They're doing basic sanity checks, right? We can include security sanity checks in that too. We can say, are you including printf, right? Are you including stir memcopy? Are you including dangerous functions that we know are vulnerable to buffer overflows? If you are, you fail the build, period. Go back and do it differently. We can automate attacks against pre-production code. So part of the check-in process, we can actually go through and do like spin up bots and throw them at it. And we'll talk a little bit about that in a second. And that'll prevent vulnerable code from reaching production, hopefully. And then we can implement something called compliance as code, right? We've got OS as code, so why can't we have compliance as code? WTF is compliance as code. Patching, policy, all these things, right? That can all be largely scripted, right? So if you think about, you've already got a process in place. Somewhere you've probably got some kind of a policy that says passwords need to be XYZ length. They need to have XYZ characters. They need to have whatever your policies are. They can't be the last 3 passwords that you've used. You've already got these guidelines in place, probably, right? You've got a policy set. Your sysadmins are going somewhere to make those changes to their systems to be compliant with that. Script it. You're already pushing OS out as code. You're already doing Puppet and Chef and Ansible and everything else to spin up new boxes. Just make a security compliance script that meets those obligations and throw it in there so that all your boxes automatically pass. The beauty of that is when the auditors come in and say, we need to know that you're meeting your compliance objectives, you can say, here's all of our boxes that were deployed with Puppet, and here's all the ones that have this script applied, and here's what the script is. Done. Check. It's really easy. The problem is setup requires time and effort, right? And especially if you're coming from a large organization where you've got a bunch of legacy applications or systems, it's going to be a huge job getting this underway. It also might involve a new way of working, right? Because your teams may not be set up to functionally do this yet. It's worth it. And if you're talking about DevOps, you should really go start with this process and just go approach it with the very realistic expectation you're going to be spending a ton of time and energy on it. Let's see. How am I doing for time? Okay, good. All right, so now I'm going to go through kind of each one of those points in detail. Can you guys see these okay? It's kind of a tough thing to see. So these are a generic representation of basically where the DevOps world is, right? So you've got a source repo up here. That's what developers are actively banging away against, right? Code there is volatile. It may or may not compile correctly. It may or may not be a feature that's actually getting developed. This is where they're spinning up ideas and toying with them and everything else. You've got a binary repo. That's where code that's been through some kind of initial peer review process, it's been through whatever your organization's first level developer checkpoint is, and says, okay, this is stable code. It's a feature we're looking to implement. We're going to check it into the binary repo, okay? Binary repos, typically, at some point, you're going to take a snapshot of those and say, this is our version, and this is going to be what we push into production. Production repo is production repo. That's where your active code is living. So the developers have this process already, right, where they've got pre-commits, which is where I'm just banging away on code and I haven't committed it yet. Continuous integration is where I've started uploading it. It does its initial checks, passes or fails. If it fails, I go back to pre-commit and fix whatever problems there are. If it passes, it goes on to acceptance, gets pushed into the binary repo at some point. and then eventually that gets pushed into production. So how do we map security into these environments, right? So we've got pre-commit. That's where we're doing threat modeling. We're going to do things like IDE checks. We're going to do peer review. In the continuous integration, somewhere between continuous integration and acceptance is where you're doing static analysis. It's where you're doing security unit testing. It's where you're doing alerting on high-risk changes. And I'll talk about that in a second, because what that means for this world is not high risk in a traditional security sense. Somewhere between acceptance and production, that's where we do dynamic analysis. That's where we're doing automated fuzzing. That's where we're doing pen testing, potentially out of band, right? So you don't hold the build up for pen testing necessarily. And then production, that's where we're doing red teaming type environments. That's where we're doing bug bounties, if your organization is mature enough to handle those. That's where you're doing incident response as well as in the production world, right? So this life cycle right here, that is your vulnerability management life cycle. You can map that directly onto the development stack. So for pre-committing, there's a couple of different tools that we have here that developers can use. So do you guys know what this is? OWASP Proactive Security Tools? I see some heads nodding. For those that don't, this is a super generic guideline that OWASP has out that just says basic level, no matter what your application is, you should probably be able to implement these things. So it's something like use encryption for sensitive data. Are you doing that, yes or no, right? So these are really basic, easy checks. It doesn't tell you how to implement them. It doesn't tell you what specific ciphers to use necessarily. It's just, here's some basic security guidelines that your application needs to meet whatever it is. Okay, so we can use this for that first level check, right? We can automatically say, if you're not meeting these, then we are not even interested in talking to you until you've met this criteria. Then we can use things like code peer review tools, right? So Garrett, Fabricator, Atlassian, Crucible. These things are already being used by your developers, probably, to talk to each other as they go through and implement changes. So here's the thing. I talked earlier about risk, right, and how we do threat modeling and risk like that. So risk for this type of thing is going to be really quick and easy. It's not going to be, hey, we found a SQL injection, that's high risk. This is going to be, do we have a framework that can handle the language that you're going to use already existing in-house? Yes or no? If no, you're now a high-risk project because we don't have tooling, we don't have expertise necessarily, right? So that's high risk. That's really easy and can be implemented at a fundamental level. Things like, yeah, I don't want to go into that actually. So anyway, we can use these code peer review tools. Part of that is we can get security folks into the developer stuff. So one way to do this, right, is you've got a security SME, maybe rotating. Maybe you split it up. You've got a crypto SME of some kind, and you've got a database SME of some kind, whatever. You've got these subject matter experts that are available to your developers so that as they start implementing stuff, they can say, hey, you know what, we need to implement crypto for this. Let's talk to our security guy and see what the right way to do this is. Make your security team work with your developers. One way to do that is with the code peer review tools. Your developers can go to the security guys and say, hey, I need to see if this looks good to you. Here's what we're trying to do. Here's the code. And your security guy can go back and review it and say, no, you guys are way off base, or no, this looks good. So commit tools. A couple different things. Do you guys know what Chef Vault is? Yep, I see some more heads nodding. Keywiz is kind of similar to that. So these are ways to manage secrets in source code repositories. I can't tell you, as a pen tester, almost always, every single test I go to, this is a finding. You guys are storing credentials of some kind, whether it's an API key, whether it's a database key, whether it's some kind of key you're storing in the code, and that's not a good idea. So use tools. There's a couple available. These I picked because they're kind of popular. They're pretty well thought out. Chef Vault is amazing, actually. Go play with that if you've never used it. It's neat. So these are ways we can manage secrets in the code base. Then we can do some, again, basic triage. So we can use things like OWASP dependency check, retire.js, bundler. All these do is say, hey, you know what? This version of a library that your application is calling is known vulnerabilities. And again, this is something that I almost always find on a pen test. I go in and I go look at the libraries that you're calling, and you're using jQuery from 2 or 3 versions back that has known cross-site scripting vulnerabilities in it. And now you've got a high finding just because you're including some library. Build that in back down the path so that as your developer checks in code the first time that he calls that library, you can say, no, that's vulnerable. Get a different version of jQuery. I broke that one out as a separate bullet just because it's commercial, and I was trying to keep this limited to open source or free as much as I could. But the source clear is a useful tool if you're looking for a commercial tool to do this type of thing. The acceptance level, this is, again, triggered by a successful commit, right? So this is after code's been developed, it's been pushed in, and now it's building successfully, whatever your version of building is. It's going into a QA environment of some kind, or UAT, whatever. So functional security testing here is going to use a fail fast approach. So we're going to do things like automated configs of the runtime environment. We're going to do dynamic scanning, right? So this is like let Nessus go nuts on your QA environment, right? This is where Nessus fits into the picture, or whatever your tool of choice is. You don't need a pen tester. It annoys me as a pen tester when somebody calls me in and says, I just want you to run a scan and give me the report, because that's so stupid. You can do this yourself. And I guarantee you it's cheaper than my salary coming in to do it as a consultant. So we have a couple of different tools for this. We can use hardening.io. Again, dynamic scanning tools. Do you guys know what OWASP Zap is? Probably, yeah. It's like Burp. It's an attack proxy. Did you know that there's a Jenkins Zap plugin? I didn't until I wrote this talk. That was pretty awesome, actually. I played with that. You can actually have Jenkins, as part of your build, run Zap against your web apps and find out if you've got basic level web app vulnerabilities in it. How about these guys? Have you heard of these? Mitten, Gauntlet, or BDD security? These are neat tools. And it's funny because the first two, Mitten and Gauntlet, they use a language called Gherkin. And BDD security uses one called Cucumber. So I don't know what the fascination is with like pickles and stuff and cucumbers in security. But they use human-readable language to define security policy rules, right? So for example, it'll say something like, Nmap must meet port 80 not open. Pass, fail. That's an easy check you can build right into your pipeline as you commit code in, right? So spin up a box in Docker, run an automated scan, use this language to define what your policies are. If you find that you violate, you fail the build. Go back and do it again, developer. And again, this makes it easier for you as a security organization because the work's kind of going back on them. If they want to take over OS roles and things like that, fine, let them. But then that means they're shouldering that responsibility with you, right? The key to that, though, is to not be a jerk about it, right? So go back and make sure you've got subject matter experts so that as your developer says, hey, I don't know what you're talking about, you've got somebody on your staff that can work with them as a trusted team member and explain what they need to do and how you can go about doing it. And then finally, production tools. This is, again, after everything's been checked in. It's all been committed. So we've got all of these tools again, right? Again, dynamic scanning tools, bug bounty programs, if you're using those. Simeon Army, do you guys know what Simeon Army is? Simeon Army is fun. So Amazon has this tool, and it's essentially, you know the quote, if you gave 10,000 monkeys, 10,000 typewriters, eventually one of them would come out with the works of Shakespeare or whatever that quote is. That's kind of the concept here. The concept is if we gave 10 million monkeys, 10 million computers, and turned them loose on our app, what would happen? So Simeon Army just represents a bunch of idiots banging away on your app and trying to break it. And they run this against production Amazon constantly, which is really interesting to me. So I'm not recommending that necessarily, unless you've got a super mature program. But run it against QA or something and just see what happens when your app breaks. Because you may not find this in QA and UAT. Having come from a QA world at one point, you're kind of giving a script, right? Like, here's what the application does. QA, go down the steps 1, 2, 3, 4, 5. Make sure that 1, 2, 3, 4, 5 work the way that we say they will. That's awesome for making sure that somebody that's not thinking about how do I break your app works, right? The problem is you go through those steps, and that's fine, but then you get your consultants in there like me to come pen test, and I say screw steps 1 through 4. What happens if I just shove 5 at you, and your app says, I don't know what to do, because nobody ever thought about that before. That's what Simeon Army is meant to kind of emulate. AWS Inspector, that's a tool that can help you go through and audit your Amazon environment. Scout 2, does anybody know what Scout 2 is? I have to pitch Scout 2. So Scout 2 is an NCC group tool, which means, bang, since that's my company. But we have, it's on GitHub. It's a really nice tool. You give it a set of AWS credentials, and it'll analyze your entire Amazon environment and infrastructure. And if you hire, I probably shouldn't say this, if you hire our company to come audit your Amazon infrastructure, this is going to be step 1 for us. So do step 1 yourself, and then you won't have to worry about our step 1 being paid for, right? So go use this tool. You can do it yourself. It's open source. You give it some credentials. We actually have a script that tells you exactly what you need to give it, and go out and do that. There's also some interesting new DevOpSec stuff. And I got to be honest, I debated even putting this slide up. Signal Sciences looks like a really cool product. There are people whose opinions I respect in the security community that give it a thumbs up. Their website is a whole lot of spin. So I haven't seen this in production yet myself, but it looks interesting, and there are people that I think are cool saying that it's a neat technology. So it might be worth checking out if you're interested in that sort of thing. They claim to be able to spin WAF technology right into your lifecycle, right? So it integrates with Puppet, it integrates with Chef, so you can just build a WAF as code. And there's some new technologies that have come out recently with like Fastly too. They've got a web application firewall now. So if you're using Fastly CDN or whatever, you can spin up a WAF in front of your tools in the cloud now. So there's some neat technology coming out of that. Wrapping up, because I think I'm about done, right? Yeah. DevOps plus security is cool. Integrating the two requires cultural shift. And I'm not going to lie about that, and don't lie to management about that. It definitely is a huge cultural shift. And if you don't get management buy-in from a top level, you're not going to succeed at this. And I guess, I'm sorry, how much time do I have? 15? Okay. I'll give just kind of a quick story about this. I interviewed at a company recently who has a really, really cool product with over 50% of the market share in what they do. And they had 0 security guys. They had, or gals, they had no security people at all. And what they do deals with schools, right? So it's a communication platform for teachers and students and parents to be able to close the gap. Really neat product. And I went out and interviewed with them to talk about, how can we bring security to your organization. And part of that is I was looking to work remote. And I was really impressed. I didn't get the job. I'm going to say that up front. But I didn't get the job for the right reason. They knew that in order to integrate security into their company, they needed somebody that could be on site because it's such a huge cultural shift. You can't do this remotely. You need that same level of awareness in your organization if you're going to succeed in marrying these two around. You need top-down push. You can't try to push it from below. It's not going to work. Again, depending on your culture. There's going to be tons to work out. It can be awesome when it's done right. Industry leaders like Amazon and Netflix have all kinds of documentation and articles and things out there about problems that they've done. There's a gentleman speaking today at 2, Troy. He's going to talk about problems that his company faced when they tried to integrate these two things and how they overcame those challenges. So if you're interested in DevOps and security, you might want to go check out his talk and see what kind of problems they ran into. And I think that's pretty much it for me. So questions, again, before I take those, you can find me there. That's my NCC group email if you want to reach out to me there.